October 3rd, 2025 now. Several spacecraft on Mars are directing their cameras at something that should not exist. An object emitting 150 kilograms of gas per second, without any recoil. It feels like a cannon firing without recoil, a violation so fundamental that when scientists first saw the data, they thought their instruments were broken. Avi Loeb from Harvard rated it 6 out of 10 on the alien technology scale, but that's not why you're here. You are here because 2 days ago, someone claiming to work with the European Space Agency leaked information, technical, detailed, full of disappointment. They described a formal working group that tried and failed to classify this object as a known type of natural body. The situation no longer makes sense, and the silence of the leadership about the cognitive dissonance it causes becomes a serious professional problem. They speak of chemistry that should not be possible. Nickel tetracarbonyl is a synthetic industrial compound emitted from a stone that is supposedly billions of years old. The dust is so strange that it took a week of recalibration before they agreed the measurements were correct. And there is a problem with the mass: 33 billion tons, compressed into 3 kilometers. The statistical odds are so poor that either our galaxy models are wrong by 10,000 times, or this object is not debris at all. But here's what complicates the situation. In 26 days, he disappears behind the sun, a perfect window hidden from every telescope on Earth. And when he returns in December, we will know if he has changed course. Because if he has, then nothing natural can explain it. There is a theory that sounds like science fiction but explains every anomaly: a gas emission without thrust, synthetic chemistry, thermal impossibility, an object with its own internal engine, not powered by the sun, but by something that originated from the Big Bang. And this can be verified. 2 predictions, both falsifiable, both to be realized within the next 3 months. This is Triad Atlas, the third interstellar object we have ever discovered, and the first that made scientists doubt whether they were looking at a comet or something pretending to be one. In the end, you will understand why some researchers no longer sleep peacefully, why the trajectory seems designed, why time is too perfect, and what will happen if the data continues to refuse to cooperate, because the walls crack and the shape of the room begins to emerge. If you're ready, like and subscribe, because this story unfolds in real time, and write in the comments where you're listening from, what time it is there, and the strangest thing that ever happened to you. Chapter 1. Moment on Mars. Something is happening right now, not tomorrow, not in some distant future, when we finally build the right telescope or send the right probe, but right now, today, October 3rd, 2025. At the moment, humanity has several spacecraft operating around Mars, all trying to capture the same object known as the Triad Atlas. He became the third confirmed interstellar visitor to our solar system, and this morning at 4 o'clock UTC, he passed within 29 million kilometers of Mars. This is the closest point he will approach any planet during his journey through our cosmic neighborhood. Time is critically important. Let me explain why. For the past 3 months, scientists have been observing this object using ground-based telescopes, while the Hubble has captured it. The James Webb Space Telescope analyzed its chemical composition. Dozens of observatories around the world tracked its movement. But there is one problem with this data: distance. When Hubble photographed the Three-Eyed Atlas on July 21st, the comet was 446 million kilometers away. This is about 3 times the distance from the Earth to the Sun. At such a distance, even the incredible optical capabilities of the Hubble can capture only a limited amount of details. But today, something has changed. The Mars Reconnaissance Orbiter, equipped with a high-resolution camera, is now 20 times closer to the Three-Eyed Atlas than the Hubble during its observation. 20 times. The difference in resolution is colossal. While Hubble saw only a blurry spot, HIROS will be able to capture details as small as 30 kilometers per pixel. If the object is indeed as large as some calculations suggest, with a diameter of 5 kilometers or more, we should see its structure, shape, and possibly even surface features. The European Space Agency is also involved in the observations. 2 spacecraft, Mars Express and ExoMars Trace Gas Orbiter, have aimed their instruments at a comet. Mars Express is equipped with a high-resolution stereo camera, while ExoMars has a color and stereo surface imaging system. Both devices were designed for photographing the surface of Mars. But for this brief moment, they are aimed at something much more unusual. And of course, there are spectrometers. Mars Express is equipped with Omega and SpyCam, while ExoMars Trace Gas Orbiter has NOMAD. These instruments do not just take pictures, they measure light. Specifically, they break down light reflected or emitted by an object into its constituent wavelengths. This data allows us to identify the chemical composition, which molecules are present, what temperatures exist, and whether the phenomenon we observe is related to the sublimation of ice or something entirely different. The official hope is that these observations will help answer several fundamental questions. What is the actual size of the core? Does it rotate? And if so, at what speed? What does the dust cloud look like up close? And, most importantly, is this just an unusually large comet behaving unusually? Or is there something fundamentally different about this object? Because here lies the tension. Based solely on brightness, when the three-eyed Atlas was first discovered in July, astronomers estimated its size to be 20 kilometers in diameter. Then, as more accurate data came in from the Vera Rubin Observatory, the estimated size of the object was reduced to 10 kilometers. Observations from the Hubble telescope at the end of July suggested that the size could be around 5.5 kilometers, while some models, depending on the surface reflectivity, indicate it could be as little as 0.04 of a kilometer. This is a vast range, from 20 kilometers to less than half a kilometer, corresponding to the difference between a small town and a large building. And this question is of great importance. If the three-axis Atlas is indeed 5 kilometers or more, it will become the most massive interstellar object ever discovered by orders of magnitude. The first interstellar visitor, Oumuamua, was estimated to be about 100 meters in diameter, shaped like a pancake, and spinning through space. The second object, 2 and inclined Borisov, could reach 600 meters and looked like a rather ordinary comet. But 5 kilometers and 33 billion tons is not just a large size, it is a statistical problem. Let me explain. Our modern models of interstellar object formation suggest that smaller fragments should significantly outnumber larger ones. For every mountain ejected from a distant solar system, there should be tens of thousands of pebble-sized debris, possibly even hundreds of thousands. The probability of detection is heavily skewed towards the appearance of smaller objects, simply because there are many more of them. Nevertheless, here we have 3 interstellar objects, and the third one is potentially 1,000 or 1,000,000 times more massive than the first. This seems wrong if our models are not mistaken, if the galaxy is not just littered with interstellar debris, but teeming with it, if the process of material ejection from solar systems is fundamentally different from what we thought, or if this object is not garbage at all. This is a question that observations from Mars should help answer. If a highly sensitive camera captures a clear image with a nuclear size of 5 kilometers, then the mass estimates will be correct, and 33 billion tons will be the hard minimum, making the statistical anomaly undeniable. If the image shows something smaller, say 1 kilometer or less, then the puzzle changes. A smaller core size at the observed brightness and material ejection means the object is extremely active, ejecting much more material than any known comet at such a distance from the Sun. In any case, something doesn't add up. What frustrates me now is that we won't know right away. The data must be sent to Earth, processed, analyzed, and verified. The European Space Agency has already stated that it does not expect impressive images from Mars Express and ExoMars Trace Gas Orbiter. Both spacecraft are designed to observe Mars, not space. At a distance of 30 million kilometers, 3 Atlas asteroids will appear as less than 1 pixel on their cameras. They may capture the gas halo around it, possibly a hint of a tail, but not the core itself. Heros is the real hope, but even then, the timelines remain uncertain. Days can turn into weeks before the processed images are published, and during this time the object continues to move. By mid-October, the 3 eyes of the Atlas will be too close to the Sun to be observed from Earth. The brilliance of the Sun will make them invisible. The perihelion, the closest point to the Sun, will be reached on October the 29th. The object will be at a distance of 1.4 astronomical units, just inside the orbit of Mars, and during this entire period from mid-October to the end of the month, it will be on the opposite side of the Sun from Earth, hidden and inaccessible for observation. It is 26 days, almost a month, and when he reappears at the beginning of December, emerging on the pre-dawn sky, we will finally be able to see him. We will be able to check its trajectory, measure its brightness, confirm whether it behaved like a normal comet during perihelion, or if something unexpected happened. But let's return to today, October 3rd, the moment of Mars. Because although the official narrative focuses on resolving the issue of size, There is another layer to this story that is less about what the cameras will capture and more about what the data has already shown. And this is where the complications begin. Chapter 2. 7 Sins Against Nature. The Heavyweight Lobby published an article on October 3rd, the same day Mars passed by. The timing was intentional. In it, he outlined what he calls the 7 anomalies of the Atlas. Not uncertainties or curious facts, but anomalies, behaviors, and characteristics that do not fit the standard model of what an interstellar comet should be. He divided them into 2 categories.
Первая категория включает 4 аномалии, которые потенциально можно объяснить или смягчить с помощью более точных данных.
The second category contains 3 anomalies that, according to him, will remain a mystery forever, as they are not related to missing information, but concern probabilities, trajectories, and time, suggesting something greater than random chance. Let's start with the first category, the explainable anomalies. Anomaly 1. Size. We have already touched on this topic. The diameter of the Atlas's 3 eyes apparently exceeds 5 kilometers, giving it a minimum mass of 33 billion tons, making it 1,000 to 1,000,000 times more massive than the 2 previous interstellar objects. The possibility of explanation here depends on whether future observations, such as today's flyby of Mars, will confirm or revise this figure. If the core turns out to be smaller, the anomaly will weaken. If it is confirmed to be 5 kilometers or more, the statistical problem will deepen. Anomaly 2. Jet. Images from the Hubble telescope show a strange element, a front jet of scattered sunlight, 10 times longer than its width, directed straight at the sun. Most comets display tails that point away from the sun due to solar wind and radiation pressure. But this jet is different. It is oriented in the opposite direction. The proposed explanation is that the 3-eye comet has a powerful gas expulsion on its sunlit side, allowing material to reflect sunlight before being repelled again. This sounds plausible, but there is one problem. A jet of gas appeared early, at a distance where most comets are still dormant, and it remained unusually bright and stable. The comet's tail truly manifested by the end of August, but only after the object came significantly closer to the sun. This delay raises questions. She suggests that the gas emission dynamics behave differently than those of a typical comet with a regular chemical composition. And this is where it gets really strange. Spectroscopic observations using the James Webb Telescope and the Very Large Telescope show that the gas cloud around Trigal contains much more nickel than iron. In normal comets, as well as in the previous interstellar comet 2I Borisov, nickel and iron are found in ratios close to those observed on the Sun, approximately balanced. But in 3 Gays, there is an extreme predominance of nickel. Nickel was detected at every stage of observations. Iron appeared only when the object was closer than 2.64 astronomical units from the Sun, and even then, the ratio of nickel to iron remained much higher than expected. Why is this important? Since nickel and iron are refractory metals, they do not sublimate or turn from solid to gas at the low temperatures characteristic of comets. The surface temperature of Trigas, even relatively close to the Sun, is too low for raw nickel to simply evaporate. Something else must be happening. Either there exists a parent molecule, a compound containing nickel that decomposes and releases nickel atoms, or the heating mechanism is unconventional. In any case, this causes confusion. But that's not all. The composition of the gas is also unusual. These comets are rich in water. As they approach the Sun, the water ice sublimates and dominates the spectrum. But Tri-I is rich in carbon dioxide. The ratio of carbon dioxide to water is 8:1, one of the highest ever recorded. This indicates that the object formed in a very cold environment, much colder than the regions typical comets of the solar system come from. And lastly, polarization. This is a technical but important point. When light is reflected off dust particles, it becomes polarized. The degree and direction of polarization indicate the size, shape, and texture of these particles. Each comet and asteroid we studied falls within a specific, predictable range. Tri-I does not fit within this range. The data on polarization was so far from what was expected that the research team initially thought there had been an error. They repeated the measurements, and the result remained the same. The only way to explain these figures is if the dust particles are fundamentally different. This is not typical silica sand or crystals of water ice, but something else. These are large, complex particles, highly porous, with an almost smoky structure. Now here is the key. These 4 anomalies are indeed strange. However, this does not necessarily call into question the comet hypothesis. More precise data may clarify the size of the object. The jet may be a rare, but natural manifestation of asymmetry in emissions. Nickel could have been obtained from an exotic parent molecule that we have not yet identified. Dust may have formed under unusual conditions of formation. This may cause discomfort, but everything is explainable. Then we move on to the second category, constant mysteries, namely the fifth anomaly, trajectory alignment. The orbit of the object named Three-Eyed Atlas is aligned with the plane of the ecliptic with an accuracy of 5 degrees. The ecliptic is a flat disk around which planets orbit the sun. Interstellar objects arriving from random directions in the galaxy must have random inclinations, some steep, some shallow, some retrograde. The probability that an object will appear on a trajectory so close to the plane of the planets is approximately 0.2%, or 1 in 500. It's not impossible. Rare events happen, but this is the first alarming sign, the sixth anomaly, the time of arrival. Here, the probability drops to a minimum. The Three-Eyed Atlas did not just arrive on trajectories coinciding with the planets. It arrived at a time that allows it to pass closely by Mars, Venus, and Jupiter. Specifically, the object will pass by Mars today, October 3rd. He could reach Venus with minimal course correction in July. He is also prepared for a relatively close pass by Jupiter in March 2026. The probability of an interstellar object randomly appearing on a trajectory at such a time to allow for such encounters is about 0.005%, or 1 in 20,000. Think about that for a moment. If you were designing a probe to visit several planets in the solar system, you would want its trajectory to intersect their orbital paths. You would plan the arrival to coincide with their positions, minimizing fuel consumption for course adjustments. This is how we design human missions. Voyager, New Horizons. We optimize the trajectory using gravitational maneuvers. Three-Eyed Atlas looks as if it was delivered. Chapter 3, Impossible Physics. Something changed 2 days ago. On October 1st, 2025, an anonymous message appeared on the 4Channel's website. Not in a scientific form or a preprint server, but in the paranormal section of the site, known more for internet folklore than serious scientific discussion. But this was not folklore. The author claimed to be a PhD candidate working with the European Space Agency, stating he had permanent access to combined observational data about the Three-Eyed Atlas, and was part of an official working group that had failed to understand this object. For several months, I was part of an official working group that tried and failed to classify the behavior of this object with any known category of natural celestial body. The official position is that the Three-Eyed Atlas is an exclusively active but otherwise natural comet. This situation can no longer continue, and the silence of the leadership regarding the cognitive dissonance it causes is becoming a serious professional problem for a growing number of people. Let's clarify. Anonymous messages on forums and unverified scientific data are not reliable information. They could be fabrications or games by someone who read articles and decided to fuel speculation. But what makes this special is the unusual level of technical details. Disappointment in tone sounds sincere, and the claims unsettlingly align well with publicly available data, adding context not found in any official statement. I am going to consider what this person said, not as a fact, but as a window into what might be happening behind the scenes when scientists encounter data that does not meet expectations. The post begins with a mention of emissions. The Three-Eyed Atlas emits about 150 kilograms of gas and dust every second. This is not speculation, it is a measurable fact. The James Webb Telescope recorded this. Spectrometers at the Very Large Telescope confirmed this data. The object is losing material. Carbon dioxide, water ice, and dust particles constantly and with great force. And, according to this researcher, it leads to nothing. Quote, "It seems like a data error until you check it 100 times with all available tools." The object emits about 150 kilograms of gas and dust every second. We see it, but it changes nothing. It's like watching a shell leave a cannon without any recoil, smoke, or explosion. This is a constant, violent event without consequences, and it is a gross violation of the fundamental laws of physics. Let me explain why this is a problem. When a comet ejects gas, it experiences thrust. Newton's third law states that for every action there is an equal and opposite reaction. Gas escapes from the surface and the comet bounces. Yes, it's insignificant, but measurable over time. This creates what astronomers call non-gravitational acceleration, a slight deviation from a purely gravitational trajectory. Every active comet shows this. Halley's Comet, Hale-Bopp Comet, and 2 other comets studied after the previous interstellar visit all exhibited measurable non-gravitational acceleration when ejecting gas near the Sun. The Three-Eyed Atlas barely shows this. There is an article published in September, authored by Richard Chloe, Avi Loeb, and Peter Weirs, analyzing 4,022 observations from 227 observatories worldwide, collected from May to September. They calculated the trajectory of the object with high precision, and then searched for deviations, remnants, any signs that gas emissions were diverting the object from its course. The upper limit they found was 0.28 angular seconds over months of observation. This corresponds to a gravitational acceleration of less than 15 meters per day squared. For an object ejecting 150 kilograms per second, this is incredibly small, almost zero. The only way to explain physics, according to the poster, is that an object must be much more massive than it appears. The only way for physics to work is if an object has the mass of a small moon, packed into a space not exceeding 2 to 3 kilometers in diameter. The lower models give us a limit of 33 billion tons, which creates a second, more serious problem. Finding a mountain on an interstellar trajectory is statistically impossible. Consider what this means. If an object with 3 eyes has enough mass to resist a recoil of 150 kilograms per second, it must be incredibly dense, much denser than ice, denser than stone, approaching the density of iron. A sphere 3 kilometers in diameter made of solid nickel would have roughly this mass, but this is not a metallic asteroid. It has a coma, a tail. It ejects gases like a comet, so the mass must be there, but somehow compatible with the volatile ice on the surface. The poster continues. Our research has only begun. Finding an object of such mass so early means that the galaxy is not just littered with debris, it is teeming with it. The models are wrong by 10,000 times. Our entire picture of what is ejected from solar systems is fundamentally, grotesquely mistaken. All this indicates that the object is not a fragment, and this quiet and horrifying conclusion is one we are strongly advised not to discuss. Stop here. Let this sink in. If the mass estimate is correct, 33 billion tons or more, then statistical models break down. Because large interstellar objects must be rare, exponentially rarer than small ones. For every mountain-sized object, there should be millions of pebbles. But we have discovered 3 interstellar objects so far. A small, pancake-like thing, a relatively ordinary comet, and now something 1,000 times more massive. The sequence has been broken. Either we are incredibly lucky, or there are far more massive interstellar objects in the galaxy than we thought, which means our understanding of planetary system formation and how material is ejected into interstellar space is fundamentally wrong. Or the third option, this object is not a fragment, but that's not all. According to the post, chemistry also makes no sense. Quote, if you look at what is actually in the gas, it gets even worse. We see pure atomic nickel evaporating. This happens at temperatures where it should be frozen. It's not gradual, like ice turning to vapor. It's an instantaneous change. Nickel production is maddeningly sensitive to sunlight. The slightest temperature change, and it simply shuts down. There is only one way to explain this: the decay of the visible molecule. The only option is nickel tetracarbonyl, a substance we use in industrial processing. This explains everything, especially why there is no iron, but it is not a natural compound. What the devil could a synthetic chemical substance be doing on a stone that we believe has been in space for billions of years? Let's talk a bit about nickel tetracarbonyl. This chemical compound has a formula consisting of nickel bonded to 4 carbon monoxide groups. At room temperature, it is a colorless, highly toxic, and volatile liquid. This compound was discovered in 1890 by chemist Ludwig Mond. It is used in industry in a process called the Mond process for purifying nickel metal. First, pure nickel is exposed to carbon monoxide under specific conditions, resulting in the formation of nickel tetracarbonyl. Then it is heated, and the compound decomposes into pure nickel. This synthetic substance is actively used in laboratories and processing plants. It does not occur in nature. According to one researcher, this is the only connection that explains the emission profile of nickel from the 3 eyes of the Atlas, its temperature sensitivity, on-off behavior, and absence of iron. But if nickel tetracarbonyl is present on a comet that is supposedly billions of years old, formed in some distant protoplanetary disk, how did it get there? Natural processes cannot create nickel tetracarbonyl. Specific conditions are needed for this. high pressure of carbon monoxide interacting with metallic nickel. Even if such conditions existed somewhere in the early solar system, this compound is unstable. It decomposes and could not survive billions of years in interstellar space unless it is being actively produced, which raises the question, by what means? Next, the discussion turns to dust. The dust it emits also raises questions. We measure how light reflects off its surface. This polarization reveals the texture of the particles. Each comet, each asteroid falls within a certain range. However, the data from this comet deviates significantly from expected values. Our director insisted we had made a mistake for almost a week until we repeated the experiment. The only way to achieve such results is if the dust particles are actually entirely different, neither sand nor ice. They are large, incredibly complex particles, black and porous like smoke. This is not natural dust. The chemistry is wrong here. The physics is wrong too. This is a completely self-consistent system of errors, as if its sole purpose is to make us doubt ourselves. Synthetic material. That's what they call it. We have public data on polarization. In September, an article was published analyzing optical observations from several telescopes. The degree of polarization for the three eyes of the Atlas was measured at -2.1% at a phase angle of about 90 degrees. Negative polarization at this angle is extremely rare. This means that light is polarized perpendicular to the scattering plane, which occurs only under very specific properties of particles, with a high degree of shape irregularity and complex internal structure. The article noted that this is unusual, but it was not stated that it is impossible. According to claims from alleged insiders, internal discussions had progressed so far that the measurements were so far beyond normal parameters that they were initially taken as a tool error until the observations were repeated and showed the same result. If the dust particles are large, complex, and porous, it indicates a formation mechanism unlike anything we see in ordinary comets. Comets shed dust when ice sublimates and ejects particles from the surface. Usually this dust is small, micron-sized, relatively simple silicate or carbon grains. But large porous particles are a different matter. It's almost like smoke. Aerosol particles. Finely divided material with a huge surface-to-volume ratio. Such dust can be obtained from burning or industrial processes, or by crushing solid material into ultra-fine powder, rather than from the sublimation of ice from stone. The post then shifts to rotation, or rather, its absence.
Hubble and Webb observe a feature that should not exist. A faint, thick smear of a tail pointing directly at the sun.
Allegedly, from its sunny side, a powerful jet of carbon dioxide erupts, strong enough to lift heavy ice particles that sunlight cannot easily repel. It is a violent directed engine. It's fine, but it doesn't rotate. We've been observing it for several consecutive days. Its brightness doesn't change even by a fraction of a percent. It's a dead straight line. A stream of such power on a rotating body would create pulsation, flickering, rhythm. We see absolute perfect stillness. Explaining the tail requires a violent directed event. Observing its light requires a completely uniform cloud. One cannot have both. One of them is a lie. Either the tail model is incorrect or this cloud is unnatural. This is subtle, but important. The three-eyed Atlas rotates and has a jet erupting from one side. We should observe periodic fluctuations in brightness as the jet comes into view and then fades away. Different parts of the core reflect sunlight towards us. This is standard behavior for comets. Curved brightness, light curves. They flicker. Three-eyed Atlas does not do this. According to this researcher, brightness is constant, stable, even. This implies one of two things. Either the object does not rotate at all, which is almost impossible for a body traveling through space for billions of years. Each collision, each gravitational interaction transmits angular momentum. Either the brightness is constant because the gas emission is absolutely symmetrical, isotropic, occurring evenly in all directions at any time. But the symmetrical pattern of gas emission does not explain the directed tail. The tail points to the sun. This requires direction, streams, asymmetry. Thus, you have two incompatible observations: a tail that demands a stream and a curve of brightness that requires symmetry. Both cannot be true unless the cloud of dust and gas around the object is separated from its rotation, or the object regulates its surface to maintain constant brightness regardless of orientation. Neither of these options is natural. Then the problem of heat arises. The thing is, the object is cold. It absorbs gigawatts of solar energy, enough to power a small city. We are calculating the energy balance, and it turns out there is a huge surplus of energy that needs to go somewhere. It should produce huge clouds of steam, but there is no water. It's like directing a heat gun at an ice cube and watching it refuse to melt. The object found a way to either eliminate or regulate the colossal thermal load to maintain its surface at a certain low temperature. Energy balance is one of the most fundamental principles of physics. The energy coming in equals the energy going out, plus or minus what is retained. For a comet approaching the sun, the incoming energy is sunlight, the outgoing energy is thermal radiation, and the latent heat of sublimation. When ice turns into gas, it absorbs energy. This is how comets remain cold. The process of sublimation acts as a heat dissipating mechanism. But if the object 3I Atlas absorbs gigawatts of solar energy and does not release proportional amounts of water vapor, where does that energy go? According to this researcher, thermodynamic models do not converge. There is an excess. Heat that should cause activity does not manifest in the expected emissions. One possibility is that the object's surface has a high reflectivity. If most of the sunlight is reflected rather than absorbed, then the incoming energy is lower. But then, the object must be brighter than it seems. Another possibility is that heat is conducted inward and accumulates in the mass of the object. However, this requires very high thermal conductivity, which is unusual for icy materials. Either heat is emitted in ranges that we do not measure, in the infrared and far infrared ranges, or the object actively regulates its surface temperature, which sounds absurd. But this is exactly what the data seems to suggest. And finally, the trajectory. And this is even before you look at the path he took to get here. His trajectory is a statistical joke. It is a perfect low angular momentum orbit that guarantees a close approach. Physicists involved in modeling such processes state plainly, there is no known natural process that could direct massive objects on such trajectories. This is not just a random encounter. By all parameters, this creature was delivered from the darkness. We have already talked about alignment with the ecliptic and the timing of encounters with planets, although probabilities. But this adds another layer, low angular momentum. This means that the orbit is not just aligned with the planets. It moves relatively slowly compared to typical interstellar speeds. Most interstellar objects rush through the solar system at speeds of tens of kilometers per second. Oumuamua was moving at 26 kilometers per second relative to the sun. Fast. Object 3I Atlas moves at a speed of about 60 kilometers per second in interstellar space. However, considering the gravity of the sun, its approaching speed turns out to be lower, almost as if it is designed to linger. The post concludes with a unifying statement. Quote, "You don't understand. None of these problems are separate. They are all symptoms of a singular, underlying illness. The reactant capable of creating a trail would make the object shimmer. But this does not happen. A body of such mass should be dead, yet it is not dead. The warmth of the sun should burn him, but if he feels nothing, then each contradiction is a wall. And we all stand here looking at the walls, refusing to see the shape of the room. This is not a failure of our models. It is a look at the mechanism working beneath them, and it is wrong. A view of a mechanism operating beneath them. This phrase evokes anxiety, suggesting that the anomalies are not errors but features, indicating that the object is not broken. It functions according to rules we do not understand. Then the researcher offers an explanation that sounds like science fiction. But, according to them, this is the only physics that makes the data consistent. Chapter 4. Chemical Nightmare. Let's talk about what actually emanates from this object, as the chemistry here is not just unusual. According to the leak of information, this is impossible. The story of nickel begins with temperature. When a very large telescope directed its ultraviolet spectrum at the object 3 Eyes of Atlas from August to September, it recorded emission lines from nickel atoms, not nickel compounds, but pure atomic nickel glowing in the spectrum, present at every stage of observation. This is the problem. Nickel is a refractory metal. Its melting point is 1,455 degrees Celsius, and its boiling point is 2,913 degrees Celsius. At the distance where the 3 Eyes of Atlas were located, the surface temperature must have been somewhere between -100 and -50 degrees Celsius, far below the point where solid nickel could sublimate into atomic vapor. And yet, it was there, emerging in measurable quantities. The official explanation in the published article is cautious. I quote from researchers, The presence of nickel and iron atoms in cometary bodies is extremely mysterious. At distances where comets are observed, the temperature is too low to vaporize silicate, sulfide, and metallic grains containing nickel and iron atoms. They suggest the presence of a visible molecule, some organic compound containing nickel that decomposes under sunlight, releasing nickel atoms. However, they do not specify what this molecule is. In nature, nickel does not form many volatile compounds. It is chemically stable and prefers to remain solid. The suspected insider goes further. He names the molecule nickel tetracarbonyl and explains why it causes deep concern. Nickel tetracarbonyl is what chemists call an organometallic compound. One nickel atom is bonded to 4 carbon monoxide groups. This liquid is at room temperature, very volatile. It boils at 43 degrees Celsius, and importantly, it is sensitive to light. If exposed to ultraviolet light, like that abundant from the sun, it decomposes. Groups of carbon monoxide detach, leaving behind pure nickel atoms. This perfectly explains the observations. Nickel tetracarbonyl on the surface, slightly warmed by sunlight, begins to sublimate. Vapor rises into space. Ultraviolet photons strike it. The molecule decomposes. An atomic nickel appears in the spectrum. And since the decomposition occurs under the influence of light rather than just heat, the production of nickel is extremely sensitive to sunlight. Even the slightest change in distance or a small shift in angle dramatically